Hi everyone. I'm going to pick up right where I left off with these notes. So if you went ahead, fantastic. We're going to see how you did. What are we doing here? We're plugging in values, making a little table of graphs. We have the, table of x and y's. Square root of 4 is 2. That would be -4. -4 plus 6 is 2. I need to get my brain warmed up. Are you warmed up for today? Why did we skip these numbers? Why did we go from -3 to 0 to 5? Do you see how I specifically picked out these x values? Because what are we getting under the square root? 0, 1, 4. And what will we get here? We'll get 9. So when we take the square root, we have whole numbers. This will be -2 times 3, -6 plus 6 is 0, which is awesome. All right, let's plot these. So there's no point here. We should really call this undefined. We will move into the word undefined as we go through the year, but it's not defined. Okay, -4, 6. Check. -3, up 4. Got it. 0, 2, and then 5, 0. All right, does that look like example 1 from before? Look at example 1, looks like that, and this looks like this. Now we know this is undefined over here. So this is actually the starting point, okay? And this one went up and to the right, and this one, so instead of going up, what direction is this one going? It's going to go down. What in our function gave us that clue? What happens when things get flipped down? What happens? There's a negative in front, right? So this one actually begins at -4, 6. Yeah, there we are. And it's going to go down. And remember, it starts at a point and it keeps going. I smudged. And it's going to just keep going with an arrow like that. All right, let's analyze this picture. What's the domain? The domain are what x values will there be points? So the x values start at x equals 4, and then they get bigger. So we're going to say the domain are all the x values greater than or equal to, I think I said 4, but it's -4, right? -4. Check. The range, where are the y values? Where do the y values begin? They begin at y equals 6, and they go down to y equals -infinity. So even though, doesn't this arrow look like it's going to the right? It will still keep going down, but just barely, very slowly. It will go all the way down to -infinity. It will never level out, which some other functions do. This is going to be all the y's below less than or equal to y equals 6. What were the coordinates of the starting point? That starting point is -4, +6. Do you see how the domain and the range tell you, go off of the starting point? What is the value of a in this example? What number is in front of the square root? A equals -2. Then describe the location of the first 3 points to the right of the starting point in relation to the starting point. Okay. So we had a good pattern before. It was the perfect square pattern, but now it's going to be a little bit different because it's a 2 and not a 1. All right, what's our pattern here? So our pattern is we went down 2 over 1, and then we're going down 4 over 4, and then down 1, 2, 3, 4, 5, 6 over 9. Let's look at this pattern. So we went down 2 over 2, down 4 over 4. Am I doing this right? I just want to double check. Yep. Okay. Down 6 over 9. This is wrong. I knew it. I had a feeling, you guys. I had a feeling. This is not over 2. Double check your graph. We went down 2 and over 1. Okay. What do we notice about 1, 4, 9? Those are all perfect squares. Yeah, but they're not 2 squared and 4 squared and 6 squared. What is 1 squared? How do we get the 1? We get the 1 from 1 squared, right? Do you see how this 2 is 1 times 2? Now, what squared gives us 4? Sorry, what's the square root of 4? 2. So 2 times 2. And the square root of 9 is 3. See how this is 3 times 2? So these were doubled, and because of that 2 there. This is, what are you supposed to notice here? You're supposed to go, oh, wow, that's neat. I noticed that. And now we're going to move on. Okay. So will you be like super tested on this box? No. Just notice it and go, aha, I noticed that. X minus h. What does x minus h mean? We don't have the formula on this paper, and that's bad. So we should always have the formula. So it goes like this. A square root x minus h plus k. It's not a song. I was just kind of sing-songing it. That's our formula. X minus h is always the inside. So our x minus h this time is x plus 4. I'm trying to record a video and people are making announcements. All right, x plus 4 equals 0, and we're going to solve for x. So we're going to subtract 4, and we get x equals 4. And what's the value of k? So k is always the number being added on the end. What's the value of k on this one? K is equal to 6. So, aha, that's where you're supposed to go. Aha. X equals 4 and k equals 6 is also the starting point. It's the same as, you guys, it's the same as the parabolas and the absolute values. Now this says take the inside, take x minus h, which is actually x plus 4, set it equal, greater than or equal to 0, and solve for x. The lights went out. You okay? Adjusting. Here we go. So we have x is greater than or equal to -4. What box does that match with? That matches with the domain. The domain. Okay. So all the numbers have to be greater than or equal to 4 in order for you to plug it in here. What happens if you plug in a number less than 4, like -5? You get a negative, right? Which is no solution. So the numbers have to be -4 or bigger. What about -6? Would that work? Nope. -7? Nope. So where do they have to start? That's what domain is, you guys. This is what we're getting used to, okay? Domain is what numbers can you plug in? Well, I can't plug in anything less than -4. So the domain are all the x values greater than or equal to -4. Conclusion. What was different about this one? That 2, right? But the starting point was the same. For square root functions in which the absolute value of a does not equal 1, describe the point pattern of the 3 points to the right of the starting point. So in this case, a was equal to 2, so it was 2 times 1, but still over 1. So still the square roots, but it was 2 times that number. So the square root of 4 is 2, because we're graphing square roots. 2 times 3, and 3 squared is 9. Like that. What do you notice about the relationship between the value of a and the first up or down move to the right of the starting point? That's like the key, okay? This stuff here is like, okay, that's good to know. All right, thumbs up, but this is the key. So let's look at the starting point. Well, you guys remember slope, right, with lines? It's kind of like slope, but it's not a line. Stay with me. This is the starting point. And what's the number in front? -2. So it's like slope. Is it slope? No, it's like slope. So to get from this point to the next point, watch, we went down 2 and over 1. Does that pattern continue? No, because it's not a line, it's not constant, it's just to get to the very next point. Down 2 and over 1. But do you see that if you only had those 2 points, could you kind of tell what direction it's going to go? Yeah, you can like predict. Let's flip to the front real quick. What number was in front of the square root here? +1. What was the first move we made? Starting here, we went up 1 over 1. Could we kind of predict what the rest would be? Just those 2 points? Yeah, is that neat? Okay, I'm going to finish B and C. What do you notice about the relationship between the value of a? Okay, so when a equals -2, we moved down 2 and to the right 1 to get the next point. Does that pattern continue? No. So do not continue pattern. It only works for one time. Based on what you have observed, what can you do to find the domain of any square root function given the equation? Okay, this is big. Ready? So instead of getting the domain from the graph, the domain is going to come from the inside. When is the inside positive? Because we're only going to get a real answer if we could take the square root of a positive number. If we take the square root of a negative, that's called imaginary. So the domain, this is a big deal, you guys. This is it, like a big conclusion. Domain of any square root function will be x minus h has to be greater than 0 or equal to. It can be 0 because we can take the square root of 0. So that's it. The inside must be greater than or equal to 0. All right, we're going to turn to the next page and see what's going on. Okay, we're going to graph these functions below, and then this is your practice here. And the back of this is a new lesson, so don't worry about that for now. Okay, you ready? I don't know how much time we're going to have, but you ready? It's going to be fun. First thing we're going to do is we're going to find where does it start. So we have x plus 5 equals 0, so x equals negative 5, and the y value of the starting point is 1. So we're going to go to negative 5, 1. Okay, that's our starting point. Now, what is a equal to? A is equal to 2. Is that positive or negative? Positive. So we're going to go up 2, not down. If it were down, we would go down. It's positive 2, so we're going to go up 2 and over 1. Remember what I said is that we kind of, once we know these 2 points, we can find the direction. Okay, so we kind of know it's going up. What would be, you can plug in more numbers, okay? If we plug in negative 3, we would get square root 2. I don't know that in my head. Negative 2, we'd get square root 3. Oh, let's plug in negative 1. If you plug in negative 1, what do we get the square root of? It'd be the square root of 4. So let's plug in negative 1. Why negative 1? It gives me a nice square root. Two times 2 is 4 plus 1 is 5. So negative 1, we go up to 5, and here we go there. And the lights popped back on. Okay, what else are we supposed to say? Domain and range. And find the zeros algebraically. Oh, there are no zeros. Does this ever cross the x-axis? No, so that's nice. Sorry. I mean, more math would be nice, wouldn't it? So no zeros. And domain. How do we find the domain? Well, you can look on the graph, or you can set the inside. The inside needs to be greater than or equal to 0. So it's going to be greater than or equal to negative 5. So all the x's go this way. And the range are all the y's greater than or equal to wherever the y value started, which is 1. Cool. All right, one more. I have time. Yay, math. Yay, math. Starting point. X plus 6 equals 0. X equals negative 6. Y equals negative 3. Negative 6, negative 3. Okay, and now is this positive or negative? Negative, so it's going to go down 1 over 1. Not 2 because it's just a 1. And it's going to go down like that. Okay. I'm rushing here. What's our domain? The domain will be greater than or equal to negative 6. And the range, that's not an R, there's an R, is all the y's are less than or equal to negative 3. There are no zeros. Isn't that funny? Because it doesn't cross the x-axis because it goes down. Okay, no zeros. You're going to practice this on graph paper. Did you bring your own, or do you need to borrow one from the teacher? Thanks for watching.